Hello everyone. So let's get started. So we'll discuss about the questions which were asked in your daily quiz for engineering mathematics course, and this is regarding the first week of fourth week of April. I mean the first quiz of the fourth week of April 25. Okay. There is second part to it, so we'll discuss that in a separate video. So let's discuss this one now. So there are 4 questions. And again, the main focus is on linear algebra topic. So let's go one by one. So this is the first question where they have given you the matrix A, which is a 3 by 3 matrix, given as follows. And they're asking you to find adjoint of adjoint of adjoint of A and the determinant of it. Okay, so these two vertical lines represent standard symbol of determinant. Is given as 16 power n. Okay, and then you are supposed to find the value of n. Okay, data entry type of question, no options are there. This is one of those questions where if you don't know how to find the adjoint of adjoint of adjoint, like the series of adjoints, you can't do anything, because one may try in exam hall to get the adjoint of A first. That will be also a 3 by 3 matrix, and then get the adjoint of that matrix again and again. So 3 times you have to repeat that process, which will take a lot of time in your exam. Not a practical way of solving anything. Okay. In such cases, it is better to leave that question and move on to the next question if you are unaware of these kind of formulae. But nonetheless, we have discussed this in our regular class in detail, because this is one of those questions which is asked periodically. And if you know the answer, you can quickly write it down, find the answer within a couple of seconds, couple of minutes. But if you don't know, you'll struggle. Okay. So let's solve this. There is a small derivation that you should know, because I can directly give you the formula, and with that we can directly solve it. But I'll just tell you how do we go about these kind of questions, because in many books or in many reference materials, these kind of things are not there. Okay, so first of all, you are supposed to use the definition of adjoint of matrix. Okay, so we know that if you multiply matrix with its adjoint, since we are talking about matrix A here, so A into adjoint of A is equal to determinant of A into In, okay, where this matrix A is a square matrix. So basically the identity matrix will also have same order. Okay, and then what we do, we basically take determinant on both sides of this equation. Okay, so this vertical lines represents determinant operator. Okay, and to solve this LHS, we use the property of matrices, where determinant of product of two matrices is equal to product of determinant of individual matrices. Okay, so this property we use in order to find determinant on the LHS. Okay, so that gives you determinant of A into determinant of adjoint of A. Okay, and on the RHS, we typically use, determinant of A is a scalar. Okay, it's a number. Determinant of any matrix is a scalar. So we use the property where if you multiply any matrix by any scalar and take the determinant of that product, it is equal to, so basically what I'm trying to tell you is determinant of matrix K into some matrix A is written as K power n into determinant of that matrix A. Okay, so we can use the same concept here, and since the matrix A, determinant of matrix A is a scalar, you can write this as that scalar power n into determinant of, or determinant of this identity matrix of same order as that of A. And we all know that determinant of identity matrix is always 1. So therefore RHS only has a determinant of A term raised to power n. Okay, and then you can see there is one determinant here, one determinant here. So what you can do is take the adjoint of A determinant term on the LHS and rest of it on the RHS. So this is the standard formula that if you know the determinant of given matrix, you can calculate the determinant of its adjoint directly, okay, using this formula. But if you pay attention to the question, they are not asking you to find only the determinant of adjoint of A. There is two more adjoint sides, so that is the pain here. Okay, no need to worry, because again, let's say this is equation 1. So what you are trying to do, let's go to the next slide. So basically what you are trying to do is, let's say you are trying to get the adjoint of A and determinant of whole thing. Okay, so it's a very easy derivation. Okay, after this it's just the tricky part. Okay, so what you can do is put adjoint of A as some matrix B. Okay, so in that case what happens, this becomes adjoint of matrix B. Okay, and now if you go back to equation 1, adjoint of any matrix is its determinant raised to power n minus 1. Okay, from equation 1. So here this will become determinant of matrix B raised to power n. But you can see matrix B is adjoint of A. Okay, so therefore this is nothing but adjoint of A raised to power n minus 1, determinant of adjoint of A. And now again you go back to equation 1. What is the determinant of adjoint of A? It is nothing but determinant of original matrix A raised to power n minus 1 whole raised to power n minus 1. So basically it is determinant of A power n minus 1 whole square. Okay, and that is the trick. So however many times you take the adjoint, it will, the power of that determinant of A on the RHS will just keep on increasing. So what I'm trying to tell you is, let's say I keep on doing adjoint and adjoint of A. Okay, so let's say this I am doing m times. Okay, in this question it is done 3 times, so m will be 3 in this question, but generally you can write this as determinant of A power n minus 1 whole raised to n. Okay, so this is a standard formula, and if you know this formula, you can solve this question quickly, which I have given in the regular classes. So let's do that. Okay, so now here in this question, m is equal to 3 in this question, because this adjoint term is repeated 3 times, no? Adjoint of A. Okay, and now on RHS you have determinant of A term, so it will be best idea to find the determinant of this matrix, no? So what I can do, see, you should know, if you're a series candidate, you should know how to find the determinant of a 3 by 3 matrix, standard way. Okay, but I'll just tell you one simpler way to do this is using the cofactor expansion, and wherever you have 0, I can use cofactor expansion to get the determinant along, let's say, first column. Okay, the typical formula that you study is nothing but cofactor expansion along first row. Okay, you can do that, you'll get the same answer. But here I'm trying to do it by first column, because there is one 0 here and then there is another 0 here. So anyway, first row or first column is fine. So determinant of A will be, since we are doing it in the first column, so this will be 2 into cofactor of 1 1 plus 1 into cofactor of second row first column, and 0 into third row first column. Okay, so this term you don't need to evaluate because it is multiplied by 0, so it goes away. And then cofactor of first element first row first column is nothing but, see, there is a formula, Cij is minus 1 raised to I plus j mij. Okay, and mij is the minor of that element. Okay, so for 1 1, this minus 1 power 2 is just 1, and C11 will be nothing but, you have to eliminate that row and that column and calculate the determinant. So that turns out to be 4 into 4, that is 2 into 2 is 4, minus 1 is 5. So this will be 5. This will be 1, because that is the second element in that first column. C21 will have one minus 1 term here. And if I eliminate second row first column, the minor is just 2. Okay, so it is 10 minus 2. So determinant of this matrix is 8. Okay, and you can use that in the derivation. So therefore the determinant of adjoint of adjoint of adjoint of A, which is nothing but, see, A is a 3 by 3 matrix, so n minus 1 is 3 minus 1 and whole raised to 3. Okay, since n is also 3 and m is also 3 in this question. Okay, and that comes out to be determinant of A raised to 2 cube, so that is 8. And determinant of A we just calculated, it is 8. Okay, so therefore this is just 8 power 8. Okay, but they are not asking you to find this quantity. What they are asking you to find in this question is nothing but this is equal to 16 power n, so you are supposed to find that n. Okay, so this is supposed to be 16 power n. Okay, now one thing you can do is nothing but take log base 2 on both sides and solve, but you know that 8, 16, these are all powers of 2, no? So what you can do, you can just write this LHS as 2 cube raised to 8, and 16 is nothing but 2 power 4 raised to n. Okay, and then power gets multiplied, so therefore this 2 power 24 equal to 2 power 4n. Okay, and now you can compare the powers. Okay, so that means 24 has to be equal to 4n, therefore n has to be 24 by 4. Okay, so therefore n has to be 6. So this is your answer. Very interesting question. It is checking many basic concepts here also, along with that adjoint concept. Okay, and what is the answer given? 6. Okay, so that is the correct answer. Okay, so this is a very interesting question. Okay, and now let's move on to the next question, which is again they have given you a 3 by 3 matrix A, and one vector is also given, column vector, and what they are saying is this vector x is the solution to this system of equation Ax equal to b, and which of the following is true for this. Okay, so this is our standard system of equation problem, and since this vector b, which is column vector, is not 0, this is non-homogeneous system of equation, and for solving such equation you are always supposed to start with the augmented matrix. Okay, an augmented matrix is given by your coefficient matrix A, and you just add one more column to it, which is your this matrix, what you say, coefficient, I mean that non-homogeneous part of the matrix. Okay, and then if you do that, what do you get? You get a 3 row 4 column matrix. Okay, so let me write it again. So 202, 327, 315, 202, 327, 315, okay, and 445. This is your augmented matrix, and now you are supposed to do the Gauss elimination operations, elementary operations on this, and get the rank of this adjoint augmented matrix, compare it with the rank of coefficient matrix. So that is first 3 columns, and then you can say depending on those ranks what is the nature of the solution of this system of equation. But see, the first thing that you should know here is you are supposed to start with making this first pivot element as 1. Okay, because then only you can eliminate the rest of the entries of this first column. Okay, so the first operation that you are supposed to do is divide R1 by 2. Okay, so if you do that, what do you get? You'll get 1 0 1, and this will become 2. Other rows remain unchanged because we don't change anything there. Okay, so this will be 315, this is 45. Okay, and now eliminate these 3 3s. So what you can do is R2 minus 3 R1. Similarly, from R3 subtract 3 R1, so that these two elements will become 0. Okay, so let's do that. So what do you get? The first row is 102, and you'll have 2 here. That remains as it is. These two elements will go to 0. And now R2 minus R3, no? So 2 minus 0, so 7 minus 3 is 4. So 2, 4, and minus 2. Okay, so 2, 4, minus 2. And in the third row, it will become again 1, 2, and minus 1. Okay. Okay. And now if you pay attention to the R2 and R3, you'll realize that, this R2 is just 2 times of R3. Okay. So what you can do is, subtract R2 minus R3. So if you do that, and R3 remains unchanged because we are not doing anything there, and this row will become 0, 2 minus, let's say 2R3, not R3, 2R3. So that will be 0, 4 minus 4, 0, minus 2 minus minus 2, that is also minus 2 plus 2, 0. Okay. So now you can see here, then you can interchange R2 and R3 so that you can write it in a standard form. So that is possible. You can swap the rows and columns, it doesn't matter. Okay, so 1, 0, 2, 2, 0, 1, 2, minus 1, 0, 0, 0, 0. Okay, but the important part here that you should notice is the rank. Okay, so the rank of your coefficient matrix is also 2. Rank is nothing but non-zero, number of non-zero rows in the Gauss elimination form. And rank of your augmented matrix is also 2. Okay, so therefore, there are some standard cases. So here, since this rank of A and rank of B are equal, but they are less than the number of unknowns, which are 3 unknowns here, x, y, z. So since rank of A is equal to rank of augmented matrix is 2, but that is less than 3, which are the number of unknowns, x, y, z. Okay. So therefore, this is the infinite solution case. Okay, so infinite solutions exist for this kind of system of equations. Okay, so that is option B. Yeah, so option B is correct, and that is the correct answer also. Okay, so this is how you are supposed to solve this question. This is a typical question asked in different ways. Again, here also you can see it is the same type of question, just the flavor changes, but the process is same. You are supposed to do the Gauss elimination, and then depending on the rank of coefficient matrix, rank of augmented matrix, and number of unknowns, you are supposed to find the answer. Okay, so same thing we have to do in this third question as well. They have given you 3 equations, and what you are supposed to find is for which value of k this system does not have a solution. Okay, this also can be written as system of equation is inconsistent. Okay, so we have to find that k. The good thing is they have given you 4 options, and one of them is only the correct option. Okay, so let's do that. Let's write this system of equations in the augmented matrix for this system of equations. Okay, this is typically the notation. A represents coefficient matrix, B represents the non-homogeneous elements. Okay, so here it will be k11, 1kk, 11k, k11, 1k1, 1k, and then you'll have the 1k and k cube. Okay, so this will be your last column. Okay, now you can't start with k as the pivot element because that is a tedious thing to do. So simple thing that you can do is first only swap R1 and R2. If you do that, this will become 1k1, k, k1, 1, 1, and 1, 1k. Third row remains unchanged. We are not doing anything to the third row. And now the things will become simpler because the process is same. So what you are supposed to do here is R2, change it to R2 minus k R1, so that the first column element, second row first column element goes to 0. Similarly, R3, change it to R3 minus R1, so that this element goes away. I mean it becomes 0. Okay, so let's do that and see what we get. So the first row will remain as it is, so that will be 1k1k. Yeah, no, sorry. Yeah, the second row and third row, these two elements will become 0 0, and this becomes 1 minus k square and 1 minus k and 1 minus k square. Okay, so this becomes 1 minus k square, this becomes 1 minus k, this also becomes 1 minus k square. Okay, what about the R3? So 1 minus k, k minus 1, k cube minus k. 1 minus k, k minus 1, k cube minus k. Okay. And now you are supposed to eliminate this element. Okay. So how do you do that? See, basically 1 minus k square, you can write it as 1 minus k, 1 plus k, right? A plus b into a minus b, a square minus b square. So what we can do is, while subtracting from R3, multiply R3 by 1 plus k and subtract R2 from it. Okay. So that what happens, the first row is as it is not changing. Second row also doesn't change because we are not doing anything to it. Okay. And this element also becomes 0. This also becomes 0. The last element, I'll write it slightly separately because it's a lengthy expression. So that is nothing but 1 plus k into R3 is k minus 1 minus R2. Okay, so R2 was 1 minus k here. Okay. So, you can take, see, let it be like this, k minus 1. What you can do, make it plus and you can write this as k minus 1. And why do we do that is because then you can take k minus 1 common from both the brackets. Okay. This becomes k minus 1 into 1 plus k plus 1. Okay, so that is k plus 2. So k minus 1 into k plus 2 is your third row, third column element. Okay. And let's talk about this last element, okay, here. So what we are doing is we are multiplying by 1 plus k to k cube minus k and then subtracting 1 minus k square from it, okay, which is coming from R2. Okay, so what you can do is, again, simple manipulation you can do. You can take k common from that k cube minus k, and this will become k square minus 1. You can take that term common from both the sides. Okay, and you will have k into 1 plus k plus 1 here. Okay, so therefore your term is k square minus 1 into k square plus k plus 1. Okay, and now the question is solved because, see, after this, what they're asking in the question is, does not have the solution. And that happens when your rank of your coefficient matrix is, see, if the ranks are same, between the coefficient matrix and augmented matrix, the basically you'll have unique solution or infinite solutions. Okay, but in some cases where rank of A is not equal to rank of your augmented matrix, that is the case where you have no solution case, inconsistent system of equation, and this inequality can be replaced by less than or less than sign. Okay, because it can be only less than that. Either it can be equal to or less than. Okay, so therefore what we are trying to find is the value of k for which rank of A is less than rank of augmented matrix. Okay, so it's, and the hint is here only. See, you can see, to make rank of A less than rank of AB, what we can do is make this expression k minus 1 into k plus 2 equal to 0. Okay, so let me write it here so that you'll understand. So for rank of A less than rank of augmented matrix case, which is our required case, we should make k minus 1 into k plus 2 element as 0. Okay, and then the other side, this k square minus 1 into k square plus k plus 1, this element should not be 0. Okay, then only rank of A will be 2 and rank of augmented matrix will be 3, and then it will be an inconsistent system of equations. Okay, and now the rest of the part is easy because this happens only for k equal to 1 or k equal to minus 2. But you'll see this is not equal to 0 only for k equal to minus 2. Okay, because if you put k equal to 1, this also becomes 0, and therefore your final answer should be k equal to minus 2. Okay, and what is that option? Yeah, that is option D. Okay, and that is the correct answer. Okay, so this was also one of the interesting question. Here, apart from your knowledge of Gauss elimination technique, the knowledge of your cases of system of choices, like rank, based on rank, whether it's infinite, unique, or inconsistent, that is also used. Okay, so very good question. So now let's take the final question, which is nothing but, I think this is the simplest one out of all the lot. So they have given you a 3 by 3 matrix and they're asking you whether its eigenvalues are, but need to be careful. More than one options could be correct here. So eigenvalues of this matrix, they are asking. Determinant also they are asking. Trace. So trace here also, here from here itself you can write, because trace of this matrix will be 1 minus 1 plus 0. So that is 0. So this option is correct. Now the question is about eigenvalues and determinant. Okay, determinant also you can directly calculate, no? The matrix, the determinant of this matrix directly you can calculate is 1 into 0, and other two terms are anyway 0, so determinant is also 0. Okay, so the second statement is also correct. Now the only option that is remaining is eigenvalues. Okay, now since it's a 3 by 3 matrix, it is better to solve this conventionally. Okay, so how to find the eigenvalues? You need to write the characteristic equation, which is a minus lambda equal to 0, and that will give you 1 minus lambda 0 0 0 0. This is also 0. Minus 1 minus lambda. Okay, then you have 1 1 0, and this is 0 minus lambda, so just lambda minus lambda equal to 0. Okay, and now we can solve for lambda here. So you just have to expand. Okay, so this is minus 1 minus lambda into minus lambda minus 0, and all two terms are 0, so that don't appear here. So basically what do you have? You have lambda 1 minus lambda, and you can take minus 1 common and put it on the RHS, still it will be 0. So therefore the eigenvalues are lambda 0, lambda 1, and lambda minus 1. Okay, so these are your eigenvalues of your matrix A. Okay, so 0 1 minus 1. Yeah, so that's why the correct option should be option D, all of the above correct. Okay, so this is again checks the concept of your eigenvalues, determinant, etc., etc. And since one of the eigenvalue is 0, you can say determinant is also 0, because that is always product of eigenvalues. Okay, so yeah, I think this is the last question. Yeah, so we'll stop here and see you next time.